In this example, we're going to look at the effect of lighting in a classroom setting. We have a physics teacher, and he's randomly assigned students to two groups. One group will get natural lighting plus fluorescent lighting, but there's lots of windows and lights coming in. And the other class just is in a room where there's nothing but fluorescent lighting. And then we've got the scores that they got on a test. And we want to find out if the natural lighting is superior to the fluorescent lighting. So let's make our hypothesis. So our hypothesis, the prompt says that it's going to be a two-tailed test. So actually, we're just trying to test out to see if it's if there's a difference between natural lighting and fluorescent lighting. So hypothesis will be the test scores will be different in classes having natural lighting and fluorescent lighting. Fluorescent is one of the more difficult words to spell in English. This is a two-tailed test. As maybe people will be able to better concentrate with the windows closed. Maybe the natural lighting will make things more positive. Okay, so what we're going to do is, since these are two different samples, people have been randomly assigned to two groups. They're basically two samples. So we're going to do a t-test. We're going to compare the two averages, because that's what t-tests do. We're going to use two sample assuming equal variances. That's the test that we will use from the data analysis tool. So we go to data, data analysis. We look for the t-test that we're looking for, the two sample assuming equal variances. Click OK. And our input variable for one, the natural lighting. And then we've got the variable for two, which is the fluorescent lighting. And the hypothesized mean difference, it's practically always 0. We have labels. And the output range, choose output range, click in the box, then click over here. We press OK. Let's round off the numbers. So home, number. Make this a little wider. And so under the natural lighting, people got 16.71 versus 14, so they have a higher score. Let's look at what else we have. We have the degrees of freedom are 12, and the t-stat is 3.14. Now we want the p-value for the two-tailed test, and we got p equals 0.01. So we can so this was a significant difference, and so we can say that now what we want to do is we want to report all the averages and the sample sizes so that we know what was going on. So we can say learning was higher in natural lighting conditions, and we have the mean equals 16.71, the sample size, n equals 7. Then in fluorescent lighting conditions, and there the mean space equals space 14.00, comma, n equals 7. And this difference was significant. And we have control IT, control I. So we always want the statistic in italics, control I, and then parentheses, we put the degrees of freedom, which was 12, space equals space. So the t-value is 3.14. That's from up here. And then we do comma, and then control I, P, control I, space, equals, space, 0.01 to tails. So we had a significant difference that people did better in natural lighting than fluorescent. And so this is evidence that you should study physics with in a room with windows, because apparently we're able to focus better, at least from studying physics.